Hello everyone, my name is Darshan. So I'm from the Department of Computer Science. So I'm studying in Venkateshwara College of Engineering. So today my topic is all about decomposition techniques. In that we can see that advanced power quality analysis for modern power system. See, decomposition it comes power quality is essential for modern power systems. Voltage fluctuations are a common disturbance. So we are gonna see this in decomposition techniques. So let's go further. So existing approaches to power quality analysis. So here you can see that single point methods, multi-point methods, limited diagnosis capabilities can't lead to incorrect conclusions. More diagnostic capabilities require more measurements. So here we can see that existing approaches to power quality analysis single point methods and multi-point methods. In single point method, we can see limited diagnosis capabilities. In multi-point methods, we can see that more diagnostic capabilities. Here in single, we can see that can lead to incorrect conclusion. Here it can lead to more measurements. So these are the things. So let's move further. So the proposed approach, a novel solution. What is the novel solution? Existing method and proposed approach. So in existing methods, limited by disturbances, changing state at a frequency higher than the power frequency. So here we can see the access voltage fluctuations, propagation in the power grid, introduces a novel signal chain for effective analysis. So here we can see that the proposed approach demodulation. So here demodulation, modeling signaling and extraction. We can see that demodulator with carrier signal estimation. In modulating signal, estimated modulating signal determines voltage fluctuations. And in extraction, we can see that is an a extracting the modulating signal from an a the voltage signal. So the proposed approach demodulation, it is an a demodulation. It is an a demodulator with carrier signal estimation. Modulating signal, estimated modulating signal determines voltage fluctuation, extraction, the modulating signal from the voltage signal. So here we can see that the proposed approach, decomposition, modulating signal decomposition, decomposing the modulating signaling into component signals using DAPW. DAPW effectiveness access is a contribution of individual during distributing, disturbing loads to voltage fluctuations and the component signal. This page breaks down the modulating signal into individual components associated with the specific loads. Okay, we can see that the proposed approach in decomposition. When it comes to decomposition, we can see that modulating signal decomposition, DAPW effectiveness, component signals, in modulating signal decomposition, we can say that decomposing the modulating signal into components signals using DAPW. In DAPW effectiveness, we can say that DAPW effectiveness access the contribution of individual disturbing loads of voltage fluctuation. Next, in component signals, this stage breaks down the modeling signal into individual components associated with a specific loads. So let's move further. So here we can see that a proposed approach propagation assessment, statistical assessment, key parameters and amplitude of voltage changes. In statistical assessment, we can see the statistical assessment of voltage fluctuation propagation. In key parameters, we can see the frequency of changes in the operating state of individual sources of disturbance. in amplitude of voltage changes induced by disturbing the loads. Okay, here we can see that the proposed approach decomposition. Here we can see that propagation assessment. Propagation assessment, statistical assessment, key parameters, amplitude of voltage parameters. So research results, comparison with existing methods. Comparison with existing method, it is a proposed approach and existing methods. We can see that here in proposed approach, what we can see it is an outperforms existing methods in accuracy and robustness. In existing method, we can see the limited accuracy and robustness. So here in proposed, we can see the effectiveness maintained in both numerical simulation and laboratory studies. And in existing, we can see that may not be effective in all the conditions. Less sensitive to other disturbances in proposed and more susceptible to other disturbances. So next, we can see that it is an uh, research results, numerical simulation studies. Here we can see the 1,000 test cases randomly adopted parameters in three phases: power network, branch radial topology, and high effectiveness localizing disturbing loads. Isn't it? Research results. Okay, in decomposition techniques in software engineering, we can say research result, laboratory experiment studies, laboratory setup and effectiveness. Here we can see that these are the two methods. So three phases real power grid model and here 100 test cases with randomly adopted parameters and highly effectiveness in real world conditions and similarly result to numerical simulation studies. So here we can see that. Okay, so let's move further. Conclusion, what we can see, effective power quality analysis, accurate localization, identify source of voltage fluctuations, and distributing load parameter, determine parameter associated with individual loads, high frequency disturbances, effective for identifying disturbances, changing state at frequency higher, frequency higher than the power frequency. Okay, these are the things. So one by one slide, I will show you again. Thank you for watching. Have a good day. Okay. And this is taken by the research paper of decomposition techniques in software engineering. And thank you.